Hi, my name is Alicia Isan, and in this talk, I'm going to introduce our work on studying the backfire effects of fairness constraints. This is joint work with Alfredo Cuesta Infante and Kalyan Verma-Chinese. Algorithmic decisions often create a feedback loop, where past decisions could shape the underlying distribution of the future outcome. In one-shot classification, fairness metrics are often enforced through constraint optimization. In this work, we study if repeatedly enforcing fair decisions could lead to further disparity between population groups, which in this case we refer as backfire effects. We formulate the bottling assumptions in the lens of causal Markov decision process, which captures the causal relationships between variables in a dynamic setting. Here, the MDP models the temporal transition of the underlying distribution, and the structural causal models characterize the causal mechanism between variables at each state as a causal graph. Previous work has studied the mean effect of algorithmic decisions. Here, we propose a metric to measure the distributional effects of algorithmic decisions. We categorize the disparate impact of a policy into within-group disparity and between-group disparity. Within-group disparity happens when a policy could lead to further inequality and dichotomy within a population group. Between-group disparity happens when a policy entrains a distribution disparity between two population groups. So here the G function is some distributional matrix. For example, this could be the quantile functions or the higher order moments. Using this formulation, we theoretically characterize when would a backfire effect happens in terms of the parameters of the structural causal equations and also the distributional matrix. We also simulate on synthetic and real-world data set using a set of well-used fairness constraints. This includes unconstrained optimization, demographic parity, and equalized opportunity. In this plot, we use the mean as a distributional metric and plot the within-group and between-group disparity as a function of the structural equations for the feature update. The first key takeaway we have is that enforcing fairness constraint could actually lead to both within-group and between-group disparity. Here, we also plot the between-group disparity of each policy when using different quantile functions as a distributional matrix. The second takeaway we have is that when the target race distribution is skewed or heavy-tailed, which is common in many fairness applications, different distributional metrics could lead to different conclusions about which policy leads to the biggest backfire effects. Based on this work, we also list a few interesting future directions. The first direction is to increase the complexity of the simulation environment to reflect the nuances of real-life applications. For example, what if we have confounding variables? Will this further increase the disparity between groups? And what if there are also disparity in terms of errors in estimation of structural equations? The second direction is to design better long-term policies. So for example, can we estimate the distributional treatment effects of a policy? And could this be used to guide the design of better long-term policies? So this is the end of the talk. And if you're interested, please come to the poster session. Thanks.